So this is meant to build on the idea that we can take a complex data set, observations about the real world that are collected, in this case, in the example, about the preferences of people interviewed in Philadelphia at a geographic location represented by latitude and longitude, and in the case of your lab, human beings that died because of police violence. Okay, so we have these data sets and we're trying to make one or two observations about the whole data set, about the way the world is, so we can make the world a better place. And that's the goal in all of this: make the world a better place. Math is a tool, quantitative literacy is your friend. Okay, so here we're going to do average. See my other lectures and stuff to more on average and standard deviation. Average, right, is the one number that represents the whole data set. Sometimes it's called the middle, but just think about it's the thing that tells us the most about what a typical number in the data set is. Okay, and what we're going to do is we type in average equals to start it, and now this is going to be for minutes. We can only do quantitative ratio variables here, right? They have to have a magnitude of difference. And we start here, and you can do it like this. This is painful for how long this takes. I'll show you an easier way to do it in just a second. But what we're doing is we're using these coordinates, right? So we're starting out at G2, and we're going to go all the way down to G298. Okay, and we can see that here, G298. So it's adding all of those numbers and then dividing by the total number of people who were interviewed, which is 297. So on average, it took 17.8 minutes. How many minutes does it take you to get to work? It takes 17.8 minutes on average. There's high ones and there's low ones, but that's the average. And now the standard deviation is going to tell us some variance, and we're going to put that equal sign and just do stdev. And now we can do the same thing, where since we're in the minutes variable, it's G2 divided by G298. Sorry, not divided by, of course. That would be ridiculous. This colon, yes, that's a colon. It'll include all the observations on G between G2 and G298. We're using everything here. That's why it's a good measure. We're incorporating every number in the data set under minutes. And we get a standard deviation, which is about the size of the average. And that tells us that there's a pretty good variance, right? If the lower standard deviation would tell us that values in the data set are on average close to the mean, and a larger one tells us about the size of the average itself, tells us that there are a lot of variance. They are spread far from the mean. So what we're going to do is just measure the average and standard deviation for each of these, each of the commute variables, right? So we already did this, right, before, right? It's already set up in 1, 2, 3. See the other video. What we did is we just highlighted this and we went to sort and filter. But what we can do now is we want to take, for all the ones, do equals average, right? And we'll do G2, right? We want to know for the people who bike, how long does it take to get to work? Okay, so we're going to take the average of all the minutes values for all the people who answered 1. So we go down and it ends here at 122. Okay, 122, G122. Okay, yeah, what's wrong with that? Yep. Okay, so the average is 12. Okay, should be standard deviation. Standard deviation in minutes. No problem. Okay. Now we ended with G122, so we're going to take the average of G123. And why are we doing G123? Because that's where the 2's start, right? Remember we did this last week, right? G123. See, that's 10 here. It's the first one that switches from 1 to 2. For now, all the 2's, what was the average? And that's going to go down to 213. Okay, no problem. 213. Okay, got to get that parentheses in. Got to get that G through the eyes of a G. Okay, much higher for people who drive. Look at that. Okay, and now we take the last one. I know I'm running over here. G123. So G124. We got G124, and then it's going up to G128. Let's see. Oh, I'm sorry. That wasn't 124, was it? Where is this? 213. Mistakes. Yeah, 213. Okay. 214 to 298. If you remember, that was the last entry in the data set. Okay, so what we have here is, we see this, right? We start to 2. 1 is the header, right? And then we started at a 2, and we all the way go down to 122 because those are all the 1's. Okay, and then we have the 2's, which are going from 123 to 213, and the 3's, which is public transit, going from 214 to 298. So this is the averaging commute for minutes for each one of those groups, divided into how people transport it. So you'd say that people who bike to work actually have a shorter commute, it seems. And then you take the standard deviation and variance the same way that I have it there, and you could talk about, okay, if let's say the values were this technically, right? I'm just making this up, but we'd say there's a lower variance in the one group, which is people who bike to work. So on average, the values are closer to the mean and show less variance. And for 2 and 3, people who drove and used public transit, there's a higher variance. Okay, that about sums it up. That's what you'll be doing in this lab.